So actually, it's quite a good follow-on from the previous talk, because actually I'm going to talk about splashing, which we've already started to cover. Actually, Richard couldn't be here today. He sends his apologies. So I'm actually going to split the talk down into two sections. One about a urinal that we developed a number of years ago, for which the developments we made there have then been incorporated in some ways into the basin. And so the second part then is about the basin, and there are some pictures of the basin kicking around. So the urinal, it seems that men split into two camps: those who realise that they get a lot of splash when they use a urinal, and those that don't. And it's actually quite amazing that really there are these two distinct people. They will say, one will say, no, there's no splashing, and then the others are, yeah, there really is splashing. Richard and I realised this and discussed it quite a lot. We didn't really come up with any ideas initially, but then what you're about to see is how we then developed an anti-splash urinal. So this is a still, and it's about to be a video of some of the really early testing we did. Now, there's going to be a stream coming, but it's actually water, but you'll get the idea nonetheless. So if you could play the video. That's it. So it's quite useful, actually. The camera actually refocuses on the splash, and that's just a standard jet of water, and you can see how much splash comes off. And some men don't realise that there's that much splash. So what's going on? Why is it happening? Well, when fluid hits a surface that's 90 degrees to it, it rebounds as splash. And that's what's happening when a man uses a urinal, if they don't know how to stop the splash. It lands on the floors, it lands on walls, it lands on people's clothes, it lands on other people, and is not very nice. And as a result, you get damage to the surfaces, you get odour, and you get the spread of bacteria. Now, this is the same urinal, the same water jet, but where we direct the water jet at the side wall of the urinal. And what that means is you get a tangential angle of attack. Any splashing is dramatically reduced, but any splashing that is there is directed away from the user into the bowl. So if you could play the video. So there it's coming in the sidewall, and you can see that there's no splashing. Now, the problem with that is that it effectively requires the person that's doing the urinating to know how to misuse the product. It means that the person either has to stand offset, or they just need to make sure that they're directing things in the right direction. And basically, it's not intuitive. And so what we developed was a central fin, which gives this tangential angle of attack, and it reduces the splash. So there it is. So these are available. They've been available for a number of years, and some people may have used them. So what's happening, like I say, you get a tangential angle of attack, and you get no splash. So that's the background for what we did. And that then led on to the Hydrofin. So the same problem of splashing exists from basins, and in hospitals it's particularly important because the bacteria can go on to kill people. Now, Ideal Standard were aware of this, and they approached us to see if we could develop an anti-splash basin. Initially we were sceptical for a number of reasons, which I'll come on to, but we were very happy to look into it. So we developed a rig. So this is our rig. This is actually the rig shown twice with different basins. So we looked at a broad range of hospital basins and a broad range of taps. And we always put the taps at the right height and the right flow rate to make sure that we had repeatable results based on what the manufacturer said. Now, this is a video of that rig, and the blue paper wrapped around it, if you press play. The blue paper is there to catch the splashes. So, like I say, this is the correct height of the tap for this basin and the correct flow rate, and you can see the splash building up. In fact, we did a broad range of tests, and the splashing in some instances goes more than 2 meters beyond the basin. Now, when some architects are being advised by healthcare professionals to put basins next to every bed because they want the healthcare professionals to wash their hands, when actually what's going on is then the splashing is going on to the patient. That's not very good. And so we were sort of in complete agreement that we needed to develop an anti-splash basin. The problem that we had was that this is a tap going onto a sink. There's no hands there. So we sort of, we were saying that actually surely the hands are the problem. Well, it turns out that they're not actually. So this slide shows one of the nurses that we spoke to explaining to us how that they are taught to wash their hands. So the first picture shows her wetting her hands. The second picture shows once she's put the soap on, she's lathering her hands and she's doing all the various steps to wash her hands thoroughly. You can see that the tap is on. And then the last image shows her rinsing her hands. And the bottom line shows, the light blue shows the tap on and going onto the ceramic, and the dark blue shows the water going onto her hands. So first of all, 3/4 of the time, the water is going onto the ceramic, it's not going onto her hands. But more than that, it's important to realise that she is angling her hands in order to reduce splash. Now she can do that, but she can't stop splash coming from the ceramic. Now, what she could do is she could turn the tap off, and so we looked at that as well. Now, this image, we introduced ink into the water, and what we did was we turned the tap on and off, because we thought if the tap's not on, it's not going to be going onto the ceramic, which is great, so you're saving water, which would be a good thing, except what actually happens is you get a lot of splashing associated with the impulse of the water. And as you can see, the ink here, you actually get a bigger problem by turning the tap off than you do of having it going continually running. So this made us realise that definitely there is a problem, and definitely we could solve this using what we had developed for the urinal. Now initially we tried quick tests, small tests, to see if going down the route of the fin that we had developed for the urinal was the right route, and it turns out that it was. And we then carried on developing the fin in a variety of ways, looking at how high it needed to be. So we changed the height, we changed the width, we changed the top profile. And we also wanted to make sure that whatever we developed could work in the real world. Could it tolerate the installation being slightly offset? We know that when people are installing these things, it's not going to be perfectly aligned. So we also did tests of it being 5 millimetres out, 10 millimetres out, and so on. And this is the result. So it's a basin with a fin in it, which is effectively like we did for the urinal. And you could sort of say, gosh, that's an awful long-winded development to do something which we could have just taken from the urinal. But actually going through that process was very important in terms of the development. There was actually a lot more that we did besides looking at taps as well and things like that. Now this video, which is the last video, which you can play, is the tap, the same rig, going onto the fin. Now, I know I'm only meant to talk for 5 minutes. I've probably gone over. This video goes on for 2 minutes, and you won't really see any splashing. So we can wait a little bit. It's actually, because of that, quite a boring video. And, well, yeah. So there you go. And that's the sink.